One important way for you to let your students understand the immensity of space is to take a ruler. We measure things in this world by using rulers and tape measurements, and we have two systems of measurement. They are the same, but we just call them different. The metric system is centimeter, meters, kilometers. Then we have the other system, which is inches, feet, and miles. So, the standard ruler in most of our schools is 12 inches and 30 centimeters. That's what I grew up with in school. I'm not sure if they still use that in school. If you are measuring a human being, a ruler and a tape measure is okay. If we are measuring cities, you talk of miles and kilometers. When you get to space, a problem comes because it's so big that you now start to wonder, how do you do it? Now, the sun to the Earth is 93 million miles, or 149 million kilometers. Pluto from the sun is about 3.5 billion miles, or almost 7 billion kilometers, and a billion is 9 zeros. Now, Alpha Centauri, one of the closest stars to us, which is just by Proximal Centauri, is 25 trillion miles, or almost 43 trillion kilometers. That's the closest. What about a star that is further? So when we get to space, we tend to use other forms of measurement. One of them is the measurement of light. Light is the fastest thing in the universe. When you're looking at the sun, you are looking at the sun the way it was 8 minutes ago, not the way it is now. If the sun blows up, for example, we will not know for 8 minutes. So the light you are seeing from the sun left the sun 8 minutes ago. Even when you're watching TV, it's hard to tell. Those who are doing physics will understand that light from the TV traveled to you. It's very fast, but it's not exactly at this moment you are seeing. How would I say this? It's traveling to you. But because you are close to it, it's almost like 0.000000001 second. It's not instantaneous. Light travels. The speed of light itself is calculated, is 299,792,158 meters per second. That's how fast light goes. Now, if you consider how far the sun is 149 million kilometers. You divide it by the meters in the second. That's why it takes 8 minutes. So the nearest star to us, Proxima Centauri, is 4.3 light years away. It takes light 4 years to travel from that star to us here. Now, it doesn't take us 4 years to get there because our spaceships do not go at the speed of light. Our spaceships go much slower. In fact, we don't even go 10% of the speed of light. Our current speed right now is probably 0.01 of the speed of light. So literally, light will travel 300,000 kilometers in 1 second, and in 1 hour, light will travel about 1 billion kilometers. So using those calculations, I would like to ask everybody a question. Determine the distance of Neptune from the sun, and then determine the amount of time it takes for light to get from the sun to Neptune. It's very easy. Even if you are a history teacher, it's not really crazy mathematics, because you've got to make your students understand that this is not physics, that you have to scratch your head. This is fun. This is exciting. Anybody can tell you how far Ikija is to Oshodi, how many minutes it will take you, or Lagos to Ibadan, or Abuja to Lagos. So you don't have to be a student of maths to know that. Likewise, this as well. If light travels 300,000 kilometers per second, if light travels about 1 billion kilometers per hour, what is the distance of Neptune to the sun? One of our videos would have told you, or just check Google. Google will tell you right away. Number 1. Now, based on the speed of light, how long do you think it takes light from the sun to get to Neptune? Please do that calculation and give me the answer. In fact, give me the answer before you watch the next video.